Space looks calm from Earth, stars twinkle, the moon rises, satellites drift in silent arcs, but the deeper you look, the stranger it gets. Our solar system hides frozen corpses of planets that never formed, moons that quake and bleed, and ancient wreckage from missions that ended in silence. And beyond that, in the black, are questions we don't know how to ask and answers we might not want. And this is the iceberg of space horrors. Level 1. Planet 9. A hidden giant tugging Kuiper belt orbits. Somewhere beyond Neptune, deep in the dark reaches of our solar system, something is pulling the strings. At least that's what some scientists believe. They call it Planet 9, a theoretical, unseen planet thought to be orbiting far beyond Pluto. We haven't seen it. We haven't detected it directly. But the evidence of its presence is oddly compelling. Back in 2016, astronomers Konstantin Batygin and Mike Brown noticed a strange pattern among a group of icy objects at the edge of the solar system, in the Kuiper belt. These objects' distant, slow-moving, elongated orbits weren't acting randomly. Instead, they all seemed to be clustered together in a way that defied chance. It was as if something massive was gently tugging on them from afar. That something became known as Planet 9. If it exists, Planet 9 could be 5 to 10 times the mass of Earth, possibly a mini Neptune, and it would take between 10,000 and 20,000 years to orbit the Sun. It would be incredibly cold and incredibly far, hundreds of times farther from the Sun than Earth. So far, in fact, that current telescopes have a hard time spotting it, especially if it's passing through dense parts of the sky. This isn't the first time scientists have gone hunting for a mysterious planet. The idea of a Planet X beyond Neptune has been floating around since the 19th century, often tied to oddities in Uranus's orbit, which later turned out to be due to Neptune itself. But Planet 9 is different. It's based not on wishful thinking or blurry photographs, but on serious mathematical modeling and computer simulations. Still, not everyone is convinced. Some astronomers argue that the apparent clustering could just be a fluke, a result of small sample size or observational bias. Others propose alternative explanations. Maybe a disk of smaller objects is creating the gravitational effect, or maybe we're just misreading the data entirely. But if Planet 9 is real, it would rewrite our understanding of the solar system's outer edge. It might explain not just the strange orbits of Kuiper belt objects, but even the mysterious tilt of the Sun's axis. It could even hint at how our solar system formed, and what else might be lurking in its frozen outskirts. Tabby Star. Tabby Star, officially known as KIC 8,462,852, might look like an ordinary star at first glance, but its behavior has baffled astronomers for nearly a decade. Unlike most stars that have fairly predictable light curves, this one has shown sudden, dramatic drops in brightness, sometimes by as much as 20%, and for no clear reason. The star lies about 1,470 light-years away in the constellation Cygnus, and it first came to fame thanks to data from the Kepler Space Telescope. Kepler was designed to look for exoplanets by tracking dips in a star's light, which happen when a planet crosses in front of it. But what Kepler saw in 2015 was something very different: irregular, long-lasting dimming events that didn't match any known planetary pattern. Naturally, this weirdness sparked a firestorm of speculation. One of the more famous early ideas: an alien megastructure, like a Dyson swarm, partially blocking the star's light. This sci-fi concept involves advanced civilizations harvesting energy from a star using vast arrays of orbiting collectors. It was a long shot, sure, but the behavior was so strange that astronomers didn't immediately rule it out. Since then, scientists have looked for more grounded explanations. One theory is that a swarm of comet fragments or dust clouds could be responsible. But the dips in brightness don't follow a simple or repeating pattern. Some last days, others weeks. Some fade the star by 5%, others by 22%. And crucially, there's no corresponding rise in infrared radiation, which you'd expect if warm dust were involved. Another idea: maybe a disrupted planet or exomoon is breaking apart, with its debris cloud drifting across our line of sight. Still, that doesn't fully explain the weird timing and depth of the dimming. In 2017, researchers noticed that Tabby's star was also dimming slowly over years, not just in quick bursts. That adds another layer of mystery, one that still hasn't been solved. What we do know is this: Tabby's star isn't dying, isn't flaring, and doesn't appear to be being eaten by a black hole. But its chaotic flickering remains one of the strangest light signatures ever recorded in modern astronomy. Titan's methane lakes. Saturn's largest moon, Titan, is one of the most alien yet oddly Earth-like places in the solar system. It's the only moon with a thick atmosphere, denser even than Earth's, and the only known world, other than Earth, with stable liquids on its surface. But instead of water, Titan's lakes, rivers, and even rain are made of methane and ethane. Temperatures on Titan hover around 180 degrees C, 290 degrees F, cold enough to keep hydrocarbons in liquid form. That's what makes the methane weather cycle possible. Just like Earth has a water cycle, evaporation, condensation, rain, Titan has a methane cycle. Clouds form in the sky, methane rains down, collects in rivers, fills up lakes and seas, and eventually evaporates again. In 2007, NASA's Cassini spacecraft, which orbited Saturn for over a decade, sent back radar images confirming massive dark patches near Titan's poles. These weren't just dry basins. They were actual lakes and seas, some larger than the Great Lakes of North America. One of them, Cruithne Mare, stretches over 1,000 kilometers. What makes these lakes eerie is their complete alienness. The liquid is not water, the skies are dim and orange, and the waves, if there are any, move slowly in thick, cold methane seas under a haze-filled sky. Cassini even tried to detect wave activity and found the surfaces to be astonishingly smooth, mirror-like in some cases. Scientists think these lakes may be seasonal, growing and shrinking over Titan's 29-year orbit around the Sun. There's also evidence of rainfall patterns and even flooding events. And yet, nobody fully understands where all the methane comes from. It should have broken down over time, but something's replenishing it, possibly from Titan's interior or even volcanic-like cryogeysers. The big question is whether life, not as we know it, could exist in such an environment. Liquid methane is a terrible solvent for life as we understand it. But there are models proposing that exotic forms of life, built on different chemistries, could potentially arise in such cold, hydrocarbon-rich conditions. In short, Titan is a planet-like moon with lakes of liquid gas, methane storms, and a thick atmosphere, all frozen in a twilight world. And if we ever send a boat or submarine there, it might just be the weirdest sailing expedition in history. Jupiter's Great Red Spot. The Great Red Spot is one of the most iconic and mysterious features in our solar system. It's a massive, swirling storm in Jupiter's southern hemisphere, larger than Earth, and it's been raging for at least 350 years. When astronomers first pointed telescopes at Jupiter in the 1600s, they noticed a strange reddish oval. That same storm is still going today. This is no ordinary weather system. The Great Red Spot is an anticyclonic storm, meaning it spins counterclockwise in the southern hemisphere, and its winds reach speeds of up to 430 km/h, 270 mph. Unlike hurricanes on Earth, which burn out in days or weeks, this Jovian beast has lasted for centuries, feeding on Jupiter's immense atmospheric energy. What keeps it going? Jupiter's atmosphere is a chaotic, layered mix of gases, driven by internal heat more than sunlight. The planet emits more energy than it receives, and its fast rotation, a day on Jupiter lasts just under 10 hours, creates powerful jet streams. The red spot sits between two of these jet streams, which help trap and stabilize it like a spinning marble between two conveyor belts. But the storm is changing. Over the past century, it's been shrinking. In the late 1800s, it was more than 40,000 km wide, enough to fit nearly 3 Earths across. Today, it's closer to 13,000 km and continues to shrink by a few hundred kilometers per year. No one knows exactly why. Some scientists think it's slowly dying, while others suggest it might be compressing into a taller, deeper vortex. Its color is also a mystery. The reddish hue could be due to complex organic molecules, red phosphorus, or other chemicals reacting under Jupiter's intense UV light, but the exact compounds remain unidentified. Some days it appears pale orange. Other times it deepens into a rich crimson. It even changes with the seasons and solar cycles. One striking feature: it's so deep that spacecraft like Juno have found the storm extends over 300 kilometers into the atmosphere, far deeper than any weather system on Earth. And its sheer persistence makes it a cosmic oddity. We still don't know how it formed, what fuels its color, or how long it will last. But while Earth's storms come and go, the Great Red Spot is a reminder that in Jupiter's atmosphere, chaos can take on a form of stability and rage on through the centuries. Nemesis hypothesis. The Nemesis hypothesis is one of those eerie ideas that blends cosmic mechanics with mass extinction. It suggests that our sun might have a distant, dark companion star, one we haven't yet detected, and that it could be responsible for periodic cataclysms on Earth. The story begins with a pattern. In the 1980s, paleontologists noticed something strange in the fossil record. Mass extinctions seemed to happen roughly every 26 million years. Dinosaurs were just one chapter in a long saga of sudden die-offs. This regularity led some researchers to propose that something was disturbing the solar system on a schedule, and one wild idea was Nemesis. Nemesis was imagined as a dim, red or brown dwarf orbiting the Sun at a huge distance, perhaps 1 to 1.5 light-years away. Every 26 million years or so, it would swing close enough to gravitationally jostle the Oort cloud, a vast, icy shell of comets surrounding our solar system. The disturbance would send swarms of comets inward, dramatically increasing the chances of a catastrophic impact on Earth. It's a chilling concept, a star you can't see, out there in the dark, playing cosmic billiards with our planet's fate. For a while, the idea had some traction. It even inspired NASA-funded sky surveys to look for faint stellar companions. But as infrared telescopes like WISE, Wide Field Infrared Survey Explorer, scanned the skies in the 2010s, they turned up empty. No brown dwarf, no red dwarf, no Nemesis. At least, not in the places it was supposed to be. That's led most scientists to abandon the theory, or at least set it aside. There's no solid evidence for periodic mass extinctions anymore, and our models of the Oort cloud have improved. Some researchers still consider the possibility of other kinds of distant solar system objects, like Planet 9, that might disturb orbits, but the original idea of Nemesis as a second sun is mostly shelved. George's star. When William Herschel discovered Uranus in 1781, it was a monumental moment, the first planet found with a telescope, and the first new world added to the known solar system since antiquity. But what many people don't know is that Herschel didn't want to name it Uranus. His original proposal, Georgium Sidus, or George's star. Yes, really, Herschel wanted to name the planet after King George III of England. It was meant as a gesture of loyalty and gratitude, since Herschel was a German-born musician-turned-astronomer who had moved to Britain and been generously supported by the royal court. Naming a planet after the monarch wasn't unusual by 18th century standards. Back then, astronomical discoveries often carried political or cultural weight. But not everyone was thrilled about the name. Outside of England, particularly in France, George's star didn't go over well. The French, still smarting from conflicts with Britain, weren't about to name a celestial body after their rival's king. Alternative names began circulating. One of the strongest contenders was Herschel, in honor of the discoverer himself, a tradition that had already been applied to comets. But others pushed for something that fit with the classical naming scheme of other planets, all of which were named after Roman gods. Eventually, the name Uranus gained traction. Proposed by German astronomer Johann Bode, it was meant to align with the mythological theme. Uranus was the Greek god of the sky and the father of Saturn, making the name fit nicely into the existing planetary family tree: Jupiter, son of Saturn, Saturn, son of Uranus, and so on. It took decades, but by the mid-19th century, Uranus became the officially accepted name. Still, some old star charts and documents refer to it as Georgium Sidus, a strange historical footnote that reminds us how even science isn't free from politics, pride, and a bit of royal flattery. Level 2. Triton was captured. Triton, the largest moon of Neptune, is one of the strangest major moons in the solar system, and for good reason. It orbits backward. That alone is weird. Almost every large moon orbits its planet in the same direction the planet spins, but Triton moves in the opposite direction, a retrograde orbit. This suggests one thing: Triton didn't form around Neptune. It was captured. Scientists believe Triton used to be a free-floating object in the Kuiper Belt, an icy region beyond Neptune filled with leftover debris from the solar system's formation. At some point, probably billions of years ago, Triton got too close to Neptune. A gravitational interaction, possibly involving a third body, like a binary pair or another object, caused it to be pulled in and trapped in orbit. But that capture came at a cost. When Neptune grabbed Triton, it would have disrupted any moons Neptune already had, potentially ejecting or destroying them. Triton's orbit also started out highly elliptical and unstable, but over millions of years, tidal forces circularized it, at the expense of enormous internal friction and heat. Even now, Triton's orbit is slowly decaying. In the far future, it may spiral inward and break apart, forming a temporary ring system around Neptune before crashing into the planet. In that sense, Triton is a ticking time bomb, a moon doomed by the very planet that adopted it. But there's more. Triton is geologically active. When Voyager 2 flew by in 1989, it saw something shocking: geysers shooting nitrogen gas miles into the air from the icy surface. The surface itself looks young and smooth in many places, suggesting some kind of internal heat, despite being so far from the sun. It also has a bizarre terrain: cantaloupe, textures, frozen ridges, and few impact craters. All of it points to a complicated internal history, possibly even including a subsurface ocean. Triton is big, the seventh largest moon in the solar system, and dense, which sets it apart from most small icy bodies. Its capture, retrograde orbit, and internal activity make it one of the most intriguing and haunting worlds we've found. The Arecibo message. In 1974, humanity sent its first deliberate, powerful message to the stars, a binary-coded radio transmission beamed from the Arecibo Observatory in Puerto Rico. It was a bold gesture: 1,679 bits of information aimed at a globular star cluster called M13, roughly 25,000 light-years away. The idea wasn't to start a conversation. It was to leave a mark. The message, crafted by Frank Drake, yes, of the Drake equation, Carl Sagan, and a team of scientists, was symbolic more than practical. Even if a civilization lived in M13, and even if they could decode the message, we wouldn't hear back for 50,000 years round trip. But the point wasn't reply. It was presence. It was saying, we are here. So what was in it? The 1,679 bits were chosen because that number can be arranged into a 73 by 23 grid 2 prime numbers. If a receiver lays out the bits correctly, they form a picture. It's crude, but it's there. Binary representations of numbers 110, the atomic numbers of key elements in life: hydrogen, carbon, nitrogen, oxygen, phosphorus. Formulas for DNA, a sketch of the double helix, a stick figure of a human, the dimensions of our species, a diagram of our solar system with Earth highlighted, and finally, a crude rendering of the Arecibo telescope itself. In total, it's a cosmic postcard, one only an intelligent species could both send and possibly interpret. But here's where the horror creeps in. We shouted into the void. And so far, nothing shouted back. The Arecibo message became a milestone in SETI's search for extraterrestrial intelligence, but it also triggered debate. Some scientists warn against such broadcasts. What if the wrong kind of civilization hears us? After all, the galaxy may not be friendly. Stephen Hawking, among others, cautioned that revealing our location could be like lighting a beacon for predators. The message still hangs in space, silently flying through the void. Gravitational lensing. Imagine space as a giant stretchy fabric. When you place something massive on that fabric, like a star or a galaxy, it warps the space around it, like a bowling ball sinking into a trampoline. Now imagine light traveling across that warped surface. It doesn't move in a straight line anymore, it bends. That's gravitational lensing. First predicted by Einstein's theory of general relativity in 1915, gravitational lensing wasn't just a quirky theoretical idea. It was proven in 1919, when astronomers observed stars appearing in slightly different positions during a solar eclipse. Their light had been bent by the sun's gravity. But out in deep space, the effect becomes even more dramatic. When a massive object like a galaxy cluster sits between us and something even farther away, like another galaxy, it acts like a cosmic magnifying glass. The light from that distant object is bent, warped, and sometimes even duplicated, forming arcs, rings, or stretched-out smears in the sky. These are called Einstein rings and lensed galaxies. Gravitational lensing allows us to see things that would otherwise be invisible. Distant galaxies that are too faint or too far suddenly become observable thanks to the lensing effect. But even more importantly, it lets us map the unseen. You see, most of the mass in the universe doesn't emit light. We call it dark matter, and while we can't see it directly, we can see its effects through lensing. The way background light is distorted tells us how mass is distributed, including the invisible stuff. That makes gravitational lensing one of our best tools for studying dark matter. There are two kinds: strong lensing, where you get dramatic arcs and multiple images, and weak lensing, where the distortions are subtle and need statistical analysis across thousands of galaxies. Both are powerful tools in modern astrophysics. And here's where things get eerie. Gravitational lensing lets us see behind things. It breaks our intuitive sense of space. Light doesn't travel straight. Images can be delayed, bent, or even appear in places they shouldn't. When we look into the cosmos, we're not seeing things as they are, but as gravity allows us to see them, twisted and delayed across the vast, curved canvas of spacetime. 3753 Cruithne. You've probably heard people say Earth has one moon. Technically true, but in 1997, astronomers confirmed something strange lurking in our planet's orbital neighborhood. A small asteroid called 3753 Cruithne, often nicknamed Earth's second moon. But Cruithne isn't a moon in the traditional sense. It doesn't orbit Earth. Instead, it follows a bizarre, horseshoe-shaped path around the sun that keeps it in a strange gravitational dance with our planet. From our perspective, it looks like it's looping around us, but in reality, it orbits the sun just like we do, in a pattern that echoes Earth's motion. Let's break it down. Cruithne is about 5 kilometers wide, far too small to be visible to the naked eye. It takes roughly the same time as Earth to orbit the sun, about 1 year. But because of the way gravity works, its orbit oscillates. Sometimes it seems to get ahead of Earth, and sometimes it lags behind. This creates that looping, horseshoe-shaped track when plotted from Earth's frame of reference. It never comes particularly close to us, usually staying tens of millions of kilometers away. But its orbit is tightly locked with ours in a 1:1 resonance. That means Earth and Cruithne are gravitationally synchronized, without ever colliding or getting too near. The result? A kind of cosmic tag-along. It's not a true moon, but it's also not just a random asteroid. It's a co-orbital companion, a rare kind of object that shares our space without being bound to us. Cruithne isn't alone. Astronomers have found a few other Earth co-orbitals, but this one caught public imagination because of the early second moon headlines. And while it won't crash into Earth, the orbits are stable for thousands of years. It's a reminder that space is messier than we once thought. 2. Borisov. In 2019, a strange visitor entered our solar system, one that didn't belong here. It wasn't from our sun's family of planets or comets. It had come from another star entirely. Its name was 2I/Borisov, and it was the second confirmed interstellar object ever discovered passing through our solar system. The 2I stands for second interstellar. The Borisov comes from Gennady Borisov, the amateur Ukrainian astronomer who first spotted it in August 2019 using a homemade telescope. That's right, a backyard telescope found a traveler from another star system. What made 2I Borisov unmistakably alien was its trajectory. Unlike regular comets that orbit the sun, this one was flying on a hyperbolic path, meaning it wasn't bound to our star. It was just passing through like a cosmic hitchhiker. Its velocity and angle made it clear. It came from deep interstellar space and was just swinging by before heading back out forever. Unlike the first interstellar object, Oumuamua, which was long, cigar-shaped, and never showed a tail, Borisov looked and behaved more like a traditional comet. It had a fuzzy coma and a long tail of dust and gas, the familiar features of icy bodies that warm up as they approach the sun, but its composition was different. Spectroscopic studies showed that it had unusually high levels of carbon monoxide, far more than comets in our solar system. That hinted it had formed in a much colder environment, possibly far from its original star. Borisov's speed was around 33 kilometers per second, fast enough that even the sun's gravity couldn't keep it. It flew closest to the sun in December 2019, then whipped past Earth and vanished back into the void by mid-2020. We didn't have much time to study it, but in that brief window, astronomers across the globe turned their instruments toward it. For a fleeting few months, we got a taste, a literal sample of chemistry from another star system. Miranda's chaotic terrain and Verona Rupes. Miranda, one of Uranus's moons, looks like it was assembled in a rush or blown apart and stitched back together. It's small, only about 470 kilometers across, yet it has some of the most bizarre terrain in the entire solar system. Giant cliffs, patchwork landscapes, deep canyons, and most famously, Verona Rupes, the tallest known cliff in the solar system. Let's start there. Verona Rupes is a straight drop, stretching about 20 kilometers, 12 miles from top to bottom. That's 10 times the depth of the Grand Canyon, and if you fell off the edge, you'd plummet for nearly 10 minutes, thanks to Miranda's low gravity, before hitting the icy ground. It's an unimaginably harsh and haunting feature, carved into a tiny, freezing moon that quietly orbits in the shadows of Uranus. The rest of Miranda doesn't make much more sense. When Voyager 2 flew past in 1986, the only spacecraft to ever visit, it revealed a surface broken into strange regions. Some parts looked like jigsaw puzzles, ridges and valleys running in all directions, and oval-shaped grooved structures called coronae that have no easy explanation. These coronae, Arden, Elsinore, Inverness, sound like places from Shakespeare, and that's no accident. Miranda's name and its features are all drawn from his plays. But the terrain itself is more like science fiction. Some areas look relatively smooth, suggesting resurfacing, while others are deeply scarred, hinting at ancient violence. So what happened to Miranda? One theory is that the moon was shattered by a massive impact and then reassembled by gravity. Another suggests extreme internal activity, maybe driven by tidal heating during past gravitational interactions with other moons. Whatever the cause, the result is a moon that looks like it barely survived its own past. Level 3. Saturn's rings from a destroyed moon. Saturn's rings are one of the most iconic sights in our solar system, a brilliant, shimmering halo stretching out tens of thousands of kilometers. But beneath that beauty lies a grim theory. The rings may be the remains of a moon that was torn apart. For centuries, astronomers didn't know what the rings were. Galileo first saw them in 1610 but thought they were handles or ears. It wasn't until later that we understood they were rings, and even then their origin remained a mystery. Today, thanks to missions like Cassini, we know the rings are made of billions of particles, mostly water ice, ranging from tiny grains to chunks the size of houses. They orbit Saturn in a thin, flat plane and seem stable, but they're not eternal. In fact, they may be surprisingly young. Some studies suggest they're only 100–200 million years old, very recent, cosmically speaking. So where did they come from? One leading theory is that a medium-sized icy moon, maybe about the size of Mimas, got too close to Saturn and crossed the Roche limit. That's the distance within which a planet's gravity can tear apart a moon held together only by its own gravity. When that happens, the moon can be shredded into pieces, creating a disk of debris that eventually spreads out into a ring. This kind of destruction could have been caused by a gravitational interaction with another moon, or even an asteroid impact that destabilized its orbit. Once torn apart, the icy fragments would remain in orbit, gradually flattening into the iconic rings we see today. Cassini also detected a steady rain of ring material falling into Saturn's atmosphere, meaning the rings are slowly disappearing. In the next few 100 million years, they may vanish entirely. We happen to be living at the perfect moment to witness them. Trojan asteroids at L4–L5. Trojan asteroids are like the solar system's hidden stowaways, celestial hitchhikers sharing a planet's orbit, but never crashing into it. They cluster in gravitational sweet spots called Lagrange points, specifically L4 and L5, which sit about 60 degrees ahead and behind a planet along its orbital path. Imagine them like cosmic bodyguards, keeping pace with the planet, locked in a gravitational balance between the Sun and the planet itself. The most famous Trojans are Jupiters. Thousands of them sit in two massive swarms, one leading the planet at L4 and one trailing behind at L5. These asteroids aren't tiny, either. Some are hundreds of kilometers wide, and what's eerie is how long they've been there. They're ancient, likely relics from the formation of the solar system, untouched for billions of years. But Jupiter isn't the only planet with Trojans. Neptune has them. Mars has a few. Even Earth has a couple, though they're much smaller and harder to spot. These co-orbital asteroids don't orbit the planets themselves. They orbit the Sun, just like the planet does, but they stay in a sort of gravitational lockstep. What's strange is how stable these regions are. Once an object drifts into an L4 or L5 point, it can stay there for millions, even billions of years, wobbling gently but never breaking free. It's like falling into a hammock made of gravity. There's still a lot we don't know about Trojan asteroids. Where exactly did they come from? Were they captured during planetary migration in the early solar system? Are they leftovers from failed planet formation? Some of them have very different compositions, which suggests they may have come from all over and ended up trapped in these gravitational eddies. NASA's Lucy mission, launched in 2021, is the first mission specifically designed to visit multiple Jupiter Trojans. Over the coming years, it will fly by several of them, giving us our first close-up look at these ancient, mysterious bodies. Theia impact. Long ago, over 4.5 billion years, Earth wasn't alone. A Mars-sized body, which scientists call Theia, is believed to have collided with the early Earth in one of the most violent events in planetary history. It wasn't just a glancing blow, this was a planetary-scale smash, and it changed everything. The theory goes like this. During the chaotic early days of the solar system, protoplanets were constantly forming, migrating, and colliding. Theia was one such body, forming in roughly the same orbital neighborhood as Earth. Eventually, their paths crossed, and when they did, Theia slammed into our planet at a steep angle. The impact would have been apocalyptic. Theia's iron core likely merged with Earth's, adding to our planet's mass and explaining why Earth's core is unusually large. But the outer layers of both bodies, rock, dust, molten debris, were blasted into space. What happened next was even more incredible. That debris didn't just vanish. It formed a ring around Earth, and within weeks or months, gravity pulled it together. Piece by piece, the fragments coalesced into a single, massive object, the Moon. That's right, according to this widely accepted theory, the Moon was born from planetary wreckage. It's Earth's child, forged in fire and chaos. There's a lot of evidence supporting the Theia impact model. For one, the moon's composition is nearly identical to Earth's outer layers, not something you'd expect if it were captured from elsewhere. Also, the moon lacks a large iron core, consistent with it forming from surface materials. And isotopic ratios of oxygen on Earth and the moon are nearly identical, again, suggesting a common origin. Some newer studies even suggest that Theia's remnants might still be buried deep inside Earth, as two mysterious continent-sized blobs near the core. If that's true, Earth might still carry the ghost of Theia inside it. Moonquakes. We usually think of the moon as silent and dead, a dry, lifeless rock hanging quietly in the night sky. But beneath its dusty surface, the moon moves. It shakes. It groans. These are moonquakes, and some of them are strong enough to rattle the entire lunar crust. NASA first discovered moonquakes during the Apollo missions. Between 1969 and 1972, astronauts placed seismometers on the moon's surface. What they found surprised everyone. The moon wasn't completely geologically quiet. In fact, it was quaking in several distinct ways. There are 4 types of moonquakes. First, there are deep moonquakes, happening about 700 kilometers below the surface. These are the most common, and they seem to be triggered by tidal forces, the gravitational tug-of-war between Earth and the moon. Just as the moon causes Earth's tides, Earth also flexes the moon's interior, creating strain that eventually releases in these deep quakes. Second, there are shallow moonquakes. These are far more mysterious and far more dangerous for future lunar missions. They occur closer to the surface, and some have registered up to magnitude 5.5 on the Richter scale. That's enough to crack walls and topple structures on Earth. On the moon, where there's no water or plate tectonics, the cause of these shallow quakes isn't fully understood. They may be linked to ancient tectonic stresses or ongoing cooling and shrinking of the moon's interior. Third, there are thermal quakes, small tremors caused by the extreme temperature changes between lunar day and night. When the surface heats up or cools down rapidly, it expands or contracts, creating sharp pops and cracks. Finally, there are impact moonquakes, caused by meteorites slamming into the surface. The moon has no atmosphere to burn up incoming rocks, so it takes direct hits, and those hits send shockwaves through the crust. One eerie thing about moonquakes: they last much longer than earthquakes. While an earthquake might shake for seconds or minutes, a moonquake can ring like a bell for 10, 20, even 30 minutes. That's because the moon is much drier and more rigid with less material to absorb seismic energy. For future lunar bases, moonquakes are more than just a curiosity, they're a potential hazard. Any long-term structures will need to be designed with these quakes in mind. Pluto Charon as a near-double planet system. When we think of moons, we usually picture small objects circling much larger planets like our moon orbiting Earth or Europa orbiting Jupiter. But Pluto and its largest moon, Charon, don't follow that pattern. They're not just planet and moon. There's something stranger, a binary system. 2 worlds locked in a gravitational dance, spinning around a shared center of mass that isn't even inside Pluto. Here's what makes it so weird. Charon is enormous relative to Pluto. It's over half Pluto's diameter and about 1/8 of its mass. That's like Earth having a moon the size of Mars. Because Charon is so massive compared to Pluto, the two don't orbit like a traditional planet and moon, where the moon just loops around the planet's center. Instead, both Pluto and Charon orbit a point in space between them, a gravitational balance point called the barycenter. In the case of Pluto and Charon, that barycenter isn't inside Pluto at all. It's actually out in space, hovering between them. That's why many astronomers consider Pluto, Charon to be a double dwarf planet system, not just a planet with a moon. Their interaction is intense. Both Pluto and Charon are tidally locked to each other. That means Pluto always shows the same face to Charon, and Charon always shows the same face to Pluto. They spin in perfect sync, each endlessly gazing at the same spot on the other. No other planet-moon pairing in the solar system does this. Charon's surface is dark and scarred, with a massive canyon that dwarfs the Grand Canyon, possibly formed from ancient internal activity. Pluto, on the other hand, has surprisingly diverse terrain: icy mountains, nitrogen plains, and possible subsurface oceans. The two bodies may even exchange material via seasonal frost cycles or slow impacts. Venus's slow retrograde spin and near-upright axis. Venus is Earth's twin in size and composition, but when it comes to rotation, it couldn't be more different. It spins the wrong way, and it spins incredibly slowly. In fact, Venus is the slowest rotating planet in the solar system. A single day on Venus, one full rotation, takes about 243 Earth days. That's even longer than its year, which is only 225 Earth days. But the weirdness doesn't stop there. Venus rotates in the opposite direction to most of the other planets. This is called retrograde rotation. So if you were standing on Venus, ignoring the fact that you'd be crushed, cooked, and suffocated, you'd see the sun rise in the west and set in the east. On Earth, it's the other way around. Even stranger, Venus's axis is tilted just 3 degrees. Earth has a 23.5 degrees tilt, which gives us our seasons. Venus is practically upright, but because of its retrograde spin, some scientists argue it's actually upside down, that somewhere in its early history, Venus may have been flipped over. How did this happen? The most accepted theory is that Venus suffered a massive collision early in its formation, possibly with a large protoplanet or series of impacts that altered its spin. Another possibility is that gravitational interactions with the Sun and atmosphere caused its rotation to slow and reverse over time. Venus has a thick atmosphere, over 90 times the pressure of Earth's, and it could act like a brake, grinding down rotation over billions of years. Level 4. Soyuz 11. On June 30, 1971, 3 Soviet cosmonauts, Georgy Dobrovolsky, Viktor Patsayev, and Vladislav Volkov, were returning to Earth after a historic mission. They had just spent 23 days aboard Salyut 1, the world's first space station. It was a triumph for the Soviet space program, but their re-entry ended in silence. When recovery teams opened the Soyuz 11 capsule after it landed in Kazakhstan, they found all 3 men dead in their seats. There was no fire, no explosion, no crash. They were perfectly positioned as if asleep, but they were gone. For a moment, no one understood what had happened. An investigation revealed the horrifying truth: the cabin had depressurized during descent. Somewhere high in the atmosphere, a tiny valve had opened too early, a pressure equalization valve meant to open once the capsule was safely in thicker air. But it malfunctioned and opened in vacuum. There was no backup, no space suits. Unlike American astronauts, the Soviets didn't wear pressure suits inside Soyuz. The cabin was considered sealed and safe. That decision had been made to save weight and allow 3 crew members instead of 2. The moment the valve opened, the air rushed out. The crew had maybe 30 to 40 seconds of useful consciousness. Autopsy reports showed bleeding in the lungs and ears, classic signs of exposure to vacuum. They likely lost consciousness quickly, dying of hypoxia before they could respond. One cosmonaut reportedly tried to manually close the valve, but it was too late. They are the only humans known to have died in space. Not in the spacecraft, not on the ground, but in the vacuum of space itself, more than 100 kilometers above Earth. In the aftermath, massive changes were made. Future Soyuz missions were reduced to 2 cosmonauts to allow room for pressure suits during launch and landing. Safety systems were redesigned, but the loss of Soyuz 11 cast a long shadow. The tragedy is often overshadowed by other disasters like Challenger or Columbia, but it's no less haunting. These men didn't die in fire or in a fall. They died quietly in orbit after completing a mission that had gone perfectly until the very end. It was the cost of being first, of pushing boundaries, of learning painfully what space demands from those who dare to leave Earth behind. Apollo flags turned white. When Neil Armstrong and Buzz Aldrin planted the first American flag on the moon in July 1969, it was a symbol, a bold, flutterless marker in a place where no human had ever walked before. Over the next few missions, more flags were planted. In total, 6 American flags were set up on the moon during the Apollo landings. But what's left of them now? The moon has no atmosphere, no air, no wind, no rain. That means things don't erode the same way they do on Earth. But it also means there's no protection. Every object left on the surface is exposed to unfiltered solar radiation, cosmic rays, and relentless micrometeoroid impacts. One of the first mysteries was whether the flags even survived. During Apollo 11's liftoff from the lunar surface, astronauts saw their flag fall over from the blast of the ascent engine. Later missions may have planted them more securely. But what about the color, those bright red, white, and blue stripes? According to NASA engineers and lunar scientists, the answer is grimly simple. The flags have likely turned completely white. Ultraviolet radiation from the sun is brutal without an atmosphere to block it. The intense UV exposure, along with temperature swings from -170 degrees C to +120 degrees C and constant micrometeoroid sandblasting, would have destroyed the dyes in the flag's fabric. By now, the nylon flags are likely sun-bleached, their colors faded to ghostly white if the fabric hasn't disintegrated entirely. Lunar reconnaissance orbiter images taken in recent years show that shadows from the flags are still visible at the landing sites. That suggests at least part of the flags or their poles are still standing. But those bright symbols of national pride, they've been erased by the moon itself. Martian spoon. In 2015, a strange photo taken by NASA's Curiosity rover on Mars sparked a wave of speculation, not from scientists, but from the internet. The image showed what looked like a spoon, a long, slender shape with a curved end casting a shadow over the Martian dust. It was smooth, delicate-looking, and honestly, it really did resemble a spoon. People immediately jumped on it. Was it evidence of past life? A lost relic from a forgotten Martian civilization? Proof that someone or something had once lived and eaten on the red planet? The truth, of course, is far less dramatic, but still fascinating. The spoon is an example of pareidolia, a psychological phenomenon where our brains interpret random visual patterns as familiar shapes. It's the same reason we see animals in clouds or faces in tree bark. On Mars, where the mind is already primed to search for life, pareidolia kicks in hard. In reality, the spoon is just a naturally eroded rock. Mars is filled with bizarre rock formations, shaped over millions of years by wind, dust storms, and shifting sands. The thin atmosphere means erosion happens differently than on Earth, leading to delicate arches, pillars, and even balanced stones that seem to defy gravity. The handle of the spoon is likely a small rock arm that resisted erosion better than the material around it, leaving a protruding shape. What makes this even more believable is that similar formations have been seen across the Martian landscape, not just spoons, but shapes that look like rats, lizards, statues, helmets, and even doorways. None of them are real. They're illusions, fueled by resolution limits, lighting angles, and the very human urge to find meaning in chaos. NASA scientists quickly explained the spoon as a simple wind-carved feature, but by then the internet had run wild with theories. Zuma was a US government satellite launched in complete secrecy, and then just as mysteriously lost. Officially launched by SpaceX in January 2018, Zuma was built by Northrop Grumman for an undisclosed US agency. That's already a red flag. Most satellites, even military ones, have public tracking data. Zuma had none. The mission was so classified that SpaceX's live stream cut off earlier than usual. The Falcon 9 rocket launched successfully from Cape Canaveral, deployed its first stage, and landed the booster back on Earth. Everything appeared to go perfectly, but then nothing. The satellite was never heard from again. Within hours, rumors began swirling. Anonymous sources told the press that Zuma had failed to separate from the second stage of the rocket and had plummeted back into Earth's atmosphere. SpaceX insisted their rocket performed flawlessly. Northrop Grumman, who built the adapter connecting Zuma to the rocket, refused to comment. The Department of Defense gave the usual line, "We do not comment on classified missions." So what happened? There are a few possibilities. One theory is that the payload adapter failed and Zuma never separated. If that's true, it could mean the satellite burned up in the atmosphere, an expensive loss. Another theory. Zuma worked just fine and went into stealth mode. Its mission so secret that its disappearance was part of the plan. That's not impossible. Some government satellites are designed to avoid detection. They don't transmit, don't reflect much light, and orbit in such a way that they're hard to track. The US has launched such satellites before for espionage, signals interception, or black budget experiments. The Lunar Museum, microart disc from Apollo 12. In November 1969, the Apollo 12 mission quietly delivered one of the strangest and smallest art exhibits in human history to the moon. Tucked away on one of the lunar lander's legs was a tiny ceramic disc, just 0.75 inches wide, bearing microscopic drawings by 6 major 20th century artists. The project was called the Moon Museum, and it was installed without NASA's permission. Yes, it was smuggled onto the moon. The idea came from sculptor Forrest Myers, who contacted several prominent artists, including Andy Warhol, Robert Rauschenberg, David Navros, Cleese Oldenburg, John Chamberlain, and himself. Each contributed a simple line drawing, etched onto the ceramic wafer using microfabrication technology similar to what was used for computer chips at the time. The designs are odd and playful. Warhol allegedly drew a stylized penis, though he claimed it was his initials. Others contributed abstract shapes, rocket-inspired doodles, and geometric figures. These tiny etchings were meant to represent the creativity of Earth, quietly deposited on another world. But NASA, already facing intense public scrutiny and pressure, wasn't interested in mixing high-stakes science with underground art. So Myers went rogue. According to him, a NASA engineer agreed to secretly attach the disk to the Apollo 12 lunar module before launch. It was fixed to the leg of the descent stage, the part of the lander that remains on the moon to this day. NASA has never officially confirmed this. No astronaut mentioned it, but photos from the moon show a small square patch on the lander's leg, right where Myers said it would be. And multiple people involved in the project have since backed up the story. So there it sits in the dust of the ocean of storms, stuck to a leg of a dead spacecraft, exposed to radiation, silence, and time. Golf on the Moon, Alan Shepard's Apollo 14 swings. On February 6, 1971, during the Apollo 14 mission, astronaut Alan Shepard did something no one had done before and no one has done since. He played golf on the moon. Shepard, the mission commander and the first American in space, had secretly brought a modified 6-iron head attached to the handle of a lunar excavation tool. Hidden in his space suit pocket were 2 golf balls. Toward the end of the second moonwalk, he made his move. Standing in the dusty gray regolith of the Fra Mauro Highlands, in full space gear with barely any room to swing, Shepard dropped a ball and took a shot. His first swing, more of a one-handed swipe, hit nothing but moon. The second try made contact and the ball lifted off the surface. He hit the second ball better and famously joked over the radio that it went for miles and miles and miles. In reality, it probably flew about 30-40 yards, but still, considering he was wearing a bulky suit, using one arm and playing on a world with 1/6 Earth's gravity, it was impressive. NASA wasn't thrilled with the stunt at the time. The agency was focused on serious science, and golf wasn't on the checklist. But Shepard's lunar golfing quickly became one of the most iconic and humanizing moments of the entire Apollo program. For a brief second, amid the data collection and technical procedures, a man played. Both golf balls are still up there, untouched in the silence of the moon. Decades later, satellite images from NASA's Lunar Reconnaissance Orbiter confirmed their presence near the landing site. Level 5. Heat death. The heat death of the universe sounds like a contradiction. How can something die of heat when it actually means the universe will freeze? But in physics, heat death doesn't mean everything burns up. It means everything stops. This idea comes from thermodynamics, specifically the second law, which says that in any closed system, entropy disorder always increases. Over time, energy spreads out, differences in temperature even out, and eventually, no useful energy remains to do work. The universe, being a closed system, follows the same rules. In a heat-death scenario, all stars will eventually burn out. White dwarfs will fade to black. Galaxies will stop forming. Matter will decay. Black holes will evaporate. What's left is a cold, dark, empty universe filled with low-energy particles, a thin haze of nothingness stretched across infinite space. The scary part, this isn't some far-out fantasy. It's currently the leading long-term model for the fate of the universe, assuming it continues expanding forever, which the data strongly suggests. As galaxies move farther apart and stars die off, the universe grows colder and darker. The cosmic background radiation, already just 2.7 degrees above absolute zero, will get even closer to zero. Eventually, trillions of years from now, the last star will flicker out. After that, all that remains are black dwarfs, neutron stars, black holes, and endless silence. Black holes, once thought eternal, will also vanish thanks to Hawking radiation. Over time, they will slowly leak away their mass until they, too, disappear. The timeline for this: around 10-100 years. That's a 1 followed by 100 zeros. After that, all that remains is heat death, a term that describes a universe at maximum entropy. There will be no gradients, no reactions, no life, no light. Just particles drifting in a vast, featureless expanse. False vacuum decay. Imagine that everything, all the laws of physics, the constants of nature, the very structure of reality is balanced on a plateau. It feels stable, it acts stable. But what if that plateau isn't the true bottom? What if it's just a temporary resting place and somewhere out there, a deeper, more stable state exists? That's the unsettling idea behind false vacuum decay. In quantum field theory, our universe exists in what's called a vacuum state. This vacuum isn't empty. It's the lowest energy state of all the fields that make up reality. But here's the twist. That state might not be the absolute lowest. It could be a false vacuum, a metastable state, like a ball resting in a dent on a hill rather than in the true valley below. And if that's the case, the ball could roll. At any moment, due to quantum fluctuations, the universe could spontaneously tunnel into a lower energy, true vacuum state. When that happens, it would trigger a vacuum decay. A bubble of new physics would form and expand at the speed of light, rewriting the laws of reality as it goes. Nothing survives. Inside the bubble, the constants that govern chemistry, gravity, and electromagnetism could be totally different. Atoms as we know them might not exist. Particles could have different masses or not exist at all. Life, any kind of structure, would be impossible. And because the bubble expands at light speed, we'd never see it coming. One moment you're here, the next you're not. Now, how real is this? The idea isn't just theoretical paranoia. Some versions of particle physics, especially those involving the Higgs field, suggest our universe might actually be in a false vacuum. Measurements of the Higgs boson in 2012 showed that its mass places us near a critical boundary between stability and metastability. We're teetering on the edge. Does that mean the universe could pop like a soap bubble tomorrow? Not likely. Even if false vacuum decay is real, the timescale is unpredictable. It could take longer than the current age of the universe times 1,000,000,000,000. Or it might have already happened in some far-off corner of space, and the bubble just hasn't reached us yet. Milkdromeda. In about 4.5 billion years, a titanic event will reshape the night sky. The Milky Way and the Andromeda Galaxy are on a collision course. Two massive spirals, each filled with hundreds of billions of stars, will slam into each other in a slow-motion cosmic crash that plays out over billions of years. Astronomers call the future merged galaxy Milkdromeda. Right now, Andromeda is roughly 2.5 million light-years away from us. That might sound far, but it's closing in at about 110 kilometers per second, fast enough that the two galaxies will begin merging long before the sun burns out. Unlike most objects in the expanding universe, Andromeda is moving toward us, pulled in by gravity strong enough to override cosmic expansion. When they meet, it won't be a high-speed Hollywood-style smash. Galaxies are mostly empty space. Stars within them are so far apart that actual star-on-star collisions are incredibly rare. Instead, what we'll see, if anything is still here to see it, is a graceful, chaotic swirl, tidal tails of stars flung outward, gas clouds compressed into new star-forming regions, and both galaxies gradually losing their distinct shapes. The result will likely be an elliptical galaxy, a fat, featureless blob rather than a spiral larger than either predecessor. Our solar system may survive the merger, but it won't be untouched. It could be flung to a different part of the new galaxy or even ejected into intergalactic space. During the merger, the sky will change dramatically. If Earth is still habitable, which is unlikely, given the sun's aging process, future observers would see Andromeda grow larger every night, becoming a bright, stretched arc across the sky. Eventually, the two galaxies will wrap around each other, their arms entangled in an epic cosmic dance. Fermi paradox, the great filter problem. The Fermi paradox is simple and terrifying. It asks, if the universe is so vast and intelligent life is likely, then where is everybody? There are around 100 billion stars in our galaxy alone, many with planets in the habitable zone. Multiply that across the estimated 2 trillion galaxies in the observable universe, and the odds of intelligent life elsewhere seem overwhelming. And yet we see nothing. No signals. No structures. No visits. Just silence. Physicist Enrico Fermi reportedly asked the question during a lunch conversation in 1950. His point was blunt. With so much time and so many stars, intelligent life should have emerged and spread across the galaxy by now. But there's no sign of it. Enter the idea of the Great Filter. The Great Filter is a hypothetical barrier that prevents life from advancing to the point of becoming an interstellar civilization. It's a way of explaining the silence. Somewhere along the journey from simple molecules to galaxy-spanning societies, something stops most life from getting that far. The big question is, where is the filter? If it's behind us in the past, then we've already passed the hardest step. That would be good news. Maybe life itself is incredibly rare. Maybe complex cells or intelligence or civilization is nearly impossible, and we're the exception. But if the filter is ahead of us, then we should be very worried. It would mean that civilizations like ours tend to destroy themselves through war, environmental collapse, uncontrolled AI, or something we haven't even imagined yet. The silence out there wouldn't be peaceful. It would be a graveyard. There's also a darker theory. Maybe there are civilizations, but they stay quiet, on purpose. The concept of a dark forest suggests that any civilization broadcasting its location risks being wiped out by a more advanced one. So everyone hides, and we should too. Despite decades of searching, SETI has found nothing conclusive. The WOW signal, fast radio bursts, flickering stars, all remain unexplained, but none have been confirmed as alien in origin. And that's it for today's descent into the horrors of space. From hidden planets and shattered moons to collapsing laws of reality. Let me know in the comments what kind of iceberg you want next. Don't forget to like the video, subscribe if you haven't already, and share it with someone who thinks space is peaceful. Thanks for watching, and see you in the next one.